Now, if we try to use this, or when we use this in main, right, we're going to create a time object, just like that. And let's say out here in memory, let me go ahead and finish this off. Time.setHours. Okay. So out in memory, we get a time object, and it consists of two integers, hours and minutes. Hours and minutes. And these are both integers. And after it allocates space for these two integers, we execute the default constructor. The default constructor is going to set hours to 0 and minutes to 0. Should have drawn this a little better. And then we execute the next line of the program, which in this case is going to involve calling or invoking the setHours method of the time class on this time object. And I'm passing in 5. And here we're referring, 5 is an actual parameter. Now what happens is control, if we have a bunch of statements in main, right, we call the control of execution. Control simply just executes this statement, and when it finishes, it executes the next statement, the next statement, the next statement, the next statement. Well, when we execute a method like this, just like we did when we executed the default constructor, control transfers to the method we're calling. And then when this method finishes executing, control transfers back to the statement following the method call. And that's kind of how this works. When we actually invoke this method out in memory, we get something called an activation record. And this is the memory where this method is going to run or execute. First thing that happens when we create this activation record is we allocate space for new hours, this integer. Okay? And then we copy or we map the actual parameters, in this case there's only one, to the formal parameters. And it's a one-to-one mapping. If you have methods with multiple parameters, the first actual parameter gets mapped to the first formal parameter, the second actual parameter gets mapped to the third, and so on and so forth. So this copying or mapping happens, and so that means that effectively new hours is assigned the value 5. Okay? And once it's mapped, once the runtime environment has mapped the actual parameters to the formal parameters, then it executes the body of the method. And in this case, it's very simple. It simply assigns new hours to the private data member hours. So now we're going to replace 0 with 5. Now we could do this in a slightly different way. So let's say that I declare an integer called hours, and I give it the value 10, and then I call this method again. And I pass in hours. So this is also an actual parameter. But notice I can pass in a literal. Some people call this a constant. I usually call it a literal just to differentiate it from a constant object. And here I'm passing in a variable object, right? And in fact, you can pass in any object here. It could be a constant object, it could be a variable object, it could be a literal. And now when I make this declaration, again, out in memory somewhere, I am going to allocate space for an integer and store 10 there. Well, What's happening here is I'm making a copy. So let me back up a little bit. So when the execution of this method finishes, then this activation record is released or destroyed or deallocated, and then we execute the next line of the statement. So here I've declared this integer called hours, and in the main function, and I'm assigning it 10. Well, now what I'm doing is I'm calling set hours again, so I'm going to get another activation record. And I'm copying, and this word copying is very important. I'm copying the value of hours. So again, the activation record gets created. I allocate space for the parameters, and then I copy or map the actual parameters to the formal parameters. And in so doing, I'm taking hours, the value of hours, which is 10. It's as if I passed in 10 here, and I'm assigning it or copying it into new hours. And once I've done that, once I've mapped or copied the actual parameters to the formal parameters, then I can execute the body. And new hours in this method body acts as if it were a local variable. I mean, it is local to this block. So now I can assign new hours to the private data member hours. So just like this. But the important thing here is that at this point in execution, so after I make this assignment, I actually have 3 copies of 10, and they're all different, and that's very important to understand. First of all, I've got a copy of 10 in main stored in this identifier hours. Then in my activation record, I have a copy of 10 stored under the identifier new hours, and then I have the private data member of the time object that I've declared, and it has a private data member called hours, which also has 10. Moreover, this hours, the private data member, is different than the local variable hours that I've declared here. Okay? To make this a little bit more complicated, I can actually change this to new hours. I can change this to new hours. And that will change this to new hours. But it doesn't change the execution because the parameter new hours has absolutely nothing to do with this local variable new hours in main. Okay? So very important. The other issue with these copies is I can actually make changes to the parameter new hours, and it won't change this local variable new hours back in main. So let's say, for example, here I set new hours to, I don't know, -1. Let's just do that. Okay. Let's see how this is going to execute. So let's say that I'm right here. Execution is right here. So I have this variable new hours with 10, and I'm going to call set hours and pass in this variable new hours. Okay? So I get an activation record. Activation record. And I have space for new hours. The value parameter, not this local variable, right? The local variable that I've declared here in main is over here. And maybe I should actually say that this is, well, that's fine. So this is in main, right? So I'll just say this belongs to main, or it's in the scope of main. And now I map my actual parameters to the formal parameter. So I'm copying new hours, which has the value 10, into the parameter called new hours, which has the value 10. Now that I've mapped the actual parameters to the formal parameters, I execute the body. Well, the first thing I do is I change new hours to -1. Well, I'm not changing this local variable here, main. In main, I'm changing this parameter, new hours. It gets set to -1. And now when I do this assignment, new hours, the parameter has -1, and that's what I'm storing in the private data member hours. Okay, so with value parameters, what we're doing is we're passing copies, okay, passing copies. And inside the method here, we're operating on copies, of the parameters. Well, the parameters are copies, so we're operating on copies, and the parameters are copies. Not the originals. We'll see how to do that in just a minute. So any changes that you make to the parameter here, those changes are not going to be reflected in the formal parameters. Now, of course, here you can't change a literal, but if you see out new hours here, you're going to print 10. Okay, you're going to print 10. And in fact, what happens is when you finish the execution of set hours, its activation record is destroyed. It's deallocated. So that assignment you made to new hours of -1 is gone anyway. So when we return back to main, the only new hours is the one that you declared here, and it has the value 10. So what I would encourage you to do, a little assignment, is code this up, put some cout statements, right? Put a cout statement here, put a cout statement here, and put cout statements inside the method where you're printing new hours. And, monkey around with this and change these things, okay? And see what happens. And you'll see that whatever change you make to the parameter new hours will not be reflected in the actual parameter you used back in main, okay? So give that a try.